Once ROIs are drawn and segmented, brightness histograms can be created and analyzed using the second module of the FIF Spectrometry Suite. Click on the second module button to open the Fluorescence Fluctuation Calculator window. The first thing we are going to do in this panel is open the Settings tab. In the first tab of the Settings window, we can adjust the brightness and concentration ranges as well as the bin sizes. In the Fluctuation Settings tab, the first setting that can be adjusted is the histogram bin size. In this video, we are going to adjust the histogram bin size to 200. The measuring system can be selected from the drop-down menu. The number of Gaussians to be fit to each histogram can be adjusted. However, I'm going to leave that value at 1 for the purpose of this video. The fitting method can be changed in this drop-down menu. The fitting range can be adjusted. The method can be toggled between Gaussian fitting and moment calculation. The shot noise can be input in the next pair of cells. There are two components to shot noise, slope and intercept. These values should be determined before analysis begins. The number of pixels per square micrometer is the last adjustable cell on the left side, and finally on the right bottom side, the monomeric brightness, the gamma factor, and the background intensity can all be input in those available cells. If the user is trying to determine the monomeric brightness and the true monomeric brightness is unknown, the user should take a guess at what the monomeric brightness might be until it is determined with the monomeric construct analysis. The monomeric brightness value is used to calculate the concentration values, so it's important that once the monomeric brightness is determined, it should be used at this step. For this video, we are going to use a value of 72 for the monomeric brightness, and we'll leave the other values the same. Make sure all ROIs are selected so that we can move on to the next step of calculating brightness histograms. To do that, click on the Calculator button. This function analyzes all segments in all selected ROIs to create brightness histograms for each segment. The brightness histograms are created based on the brightness of each pixel in the segment. Since each ROI has multiple segments, this process can take some time. The amount of time this process will take is based on how many ROIs were created and the number of segments in each ROI. Once all brightness histograms are created, they can be viewed with the second button in this module. After clicking the View Histograms button, a stack of histograms will appear on the screen. The histograms can be navigated by using the arrow keys at the bottom. There will be a histogram for each segment in the ROIs. The user should confirm that the histograms are well fit with a Gaussian function, which is displayed in red on each histogram. If the histograms do not clearly represent Gaussians or are not fit well with the Gaussian function, the user should adjust the histogram bin size in the Fluctuation Settings tab. Since the histograms are displaying properly in this stack, we can move on to viewing the 3D Volcano Graph and wire stack plot. When viewing the plots, the brightness and concentration ranges may need to be adjusted. Since this set of images has been analyzed previously, we can take some liberties and put some values in that are reasonable. For this sample, the brightness maximum will be set to 500 and the bin size will be set to 10. The concentration maximum will be set to 800 and the bin size will be made 20 for now. We will adjust this later when we move on to the next step in the calculation. To open the 3D volcano graph, click on the third button in the Fluctuation panel. A volcano graph should appear on the screen. There are tools that can be used to rotate and view the plot from various angles. Frequency is plotted on the vertical axis, effective brightness is plotted on one of the horizontal axes, and concentration is plotted on the last axis. The concentration range goes from 0 to 800 as specified in the settings window, and the brightness axis range is from 0 to 500, which is also specified in the settings window. The other plot generated in this module is the wire stack graph. To open that, click on the last button in the panel. The wire stack graph is generated by the cross sections of the volcano graph, separated by concentration. When viewing the plot from the side, each wire stack is generated by gathering the profile of the volcano graph at each concentration range. Each wire stack in the wire stack window is a spectrogram that can be fit with the oligomer stoichiometry analysis module. This concludes the tutorial on the fluctuation spectrometry analysis portion of this video. The next video will teach you how to fit the spectrograms using the third module.